Bengaluru, once called the Garden City and the City of Lakes, now has not too many of either gardens or lakes. Indeed, it has been in the headlines for its water issues in recent years, either for not having enough water in its taps or there being too much water in its streets and garages. In this episode, we will explore how the urban water infrastructure works, how Bengaluru got into troubled waters, and a feasible solution.
We at Rainmatter are learning about how climate change is affecting you and me. More importantly, what we can do about it. Join us as we speak with people who are working on solutions for India. Welcome to the Climate Conversations.
We talked with Vikas Brahmavar, one of the co-founders of Boson Whitewater.
So, any urban city's water demand comes from a river which passes through the rural villages and then comes to the urban setup. Now, if the rural water demand is not met because of urban demand, then there is no proper long-term solution. So, if we are able to map both rural and urban, then we truly solve the problem. So, our intention at Boson, if we are able to solve the city level wastewater issue, there is still large amount of wastewater which the centralized STPs from the government can still make it available for the rural section. And now this project makes that possible, and it's first of its kind. Biome and EFY and a lot of them started working on this many years ago. They have been working on reviving this lake in terms of most sustainable, efficient way. We got involved from 2014 onwards. We have been visiting this place and understanding what technology can bring in based on the water quality available and things like that.
What is Biome and how is it connected with Boson?
We think of ourselves as a practice to policy bridge. So we are working with communities and well diggers and plumbers and all of them on the field working, but also learning from that and trying to inform policy, inform institutions. But in the process, working with many other stakeholders like Boson and like Vikas, where we also bring the technology necessary in, bring it to bear. And so it's an ecosystem. And so we work with all the ecosystem partners and stakeholders to try and imagine and implement, sustainable and just kind of imaginations of water and sanitation for the country today.
The water that is Kaveri water goes to Bangalore. It's used. The apartments then use STP. 80% of the water is sort of sent out, lands up in various lakes, recharges the aquifers, and that water, natural filtration through the aquifers, then is taken out via wells, open wells.
And there's the adaptation of that popularly referred to as filter bore well here, which is only 80 feet or 100 feet deep, not more. It takes water from the same aquifer that an open well takes, but it consumes much less space. This system is meeting around 10% of the town's needs. It can be scaled up to 100%.
So the municipal corporation understands the need to recharge the aquifers, which is why that STP water is coming and recharging these lakes and therefore recharging the groundwater. That's the main purpose of this, right? Okay, so, and you're saying that is happening, but what are you doing that's over and above that?
So we measured the quality of water in the well, based on contaminants in that. What is the basic treatment required for that water? And then we have designed the system based on the suggestion by IISc. They've asked us to design a system. Then we have designed it based on the quality needed to make it IS 10500 standards water at the outlet of our system.
To what extent is this a model for other parts of Bangalore or other parts of the country?
We think this is a model. This is a climate adaptive, climate mitigating solution. This is a way India can learn from this place to say, how do we take treated wastewater? How do we invest so that that treated wastewater can come back into our cycle, the circular economy? We are reinventing their role to use treated wastewater, use the environmental system to improve the qualities, and then build in risk barriers like Boson Whitewater system to be able to supply it.
And the lakes are dry. Why? Why? Just because overuse or?
Two sets of reasons. One is urbanization disturbs the colorways reaching the lake. The catchment gets disturbed, and the connection between the catchment and the lake breaks down. That's the urban reason. But otherwise, it's also when you had agriculture over pumping the groundwater, which means the rain soaks up quickly, and there's not adequate runoff for it to come and reach the lakes. So these two predominant reasons.
I know Bangalore was named one of the cities that will probably hit day zero, which is no supply of water. We got a taste of it this summer, in fact. Talk us through what happened.
In terms of water availability, there is enough water in the surface, meaning wastewater all mixed together. We have large volume of water. We don't have scarcity as such. We have.
You're talking about a country level or Bangalore level?
Bangalore level.
Bangalore level. So there's enough water.
There is enough water. So whatever water comes in, Bangalore uses a small amount, but remaining goes out. So since we don't worry about what is going out of the city, we have scarcity. Now this year scarcity, so most of the lakes went for desilting. There was no water. The groundwater probably is not recharged, so people did not find enough water in the ground itself. So as a city, we don't know the volume of water available below the ground. Government doesn't know, no one knows. We know what is the volume of water on the surface. We spend some 50,000 rupees per acre for surface water management, channels, all that, but we don't know what is the volume of water below the ground. So now we have always been in a good way where there is enough water on the go. We never worried, but this year people are worried, where suddenly borewell doesn't give. What do we do? So people have started thinking.
All our water needs used to be from borewell.
Okay.
Borewell dried up. So this was the first summer of 2024 that we had this problem.
Okay.
Now, because this problem started, we understood that we have to call tankers.
Okay.
In a day, 5 to 6 tankers used to come. One tanker is 13,000 liters. That means 78,000 liters we are importing from outside.
If the distribution problem is solved, scarcity would not happen to this level. But distribution in our country does not get solved in a year's time. It takes 7 years, 10 years, that kind of time. But until then, we would have grown even faster, right? So as cities, all our cities, we will always have scarcity issue because we are growing fast. What Singapore is doing, what UK, US, all of them are doing, they're all centralized. Government takes care of wastewater going out of the city. Government takes care of incoming water coming to the city. In our city is decentralized. Centralized is there. We get municipal water, but 40-50% is a centralized, rest 50% is unorganized sector, which is managed by tankers and things like that.
And why do you think that happens?
We grew really fast, meaning planning, implementation, everything was fast. So the infrastructure was not ready to cope up with the wastewater as well as incoming waters.
But is there anything practical that can be done?
We have to do decentralized.
Decentralized. There's no other option.
There is no centralized
There's no
option.
centralized thing that now can be done for the cities that are already built in India.
Correct. It is not just India. So we have had people from Germany, Austria coming and visiting our infrastructure, because by 2030 they also go out of their existing pipeline infrastructure. They will also move to decentralized, but they are planning now.
The local government does come up with solutions. For example, Bengaluru has regulations that require that in areas with underground drainage, that apartment complexes with more than 120 apartments have to install sewage treatment plants, or STPs. The rules also say that the treated water must be reused within the complex for toilet flushing and also for any gardens within the complex.
Any large apartment needs to have sewage treatment plant. It's mandatory.
Okay.
So from the STP treated water, this is the red color one, is the raw sewage going in, red color,
okay.
right?
Okay.
The STP does it to a little better quality, which can be used for flushing and garden.
So the red goes in, it gets treated here.
Correct.
And then the yellow goes back up above the building,
flushing,
and then it applies the
flushing.
So okay, so
And this is 15% of water generally goes for flushing, 5% goes for garden. So effectively 20% gets used within the building.
Okay.
Right. The excess water from this after garden generally goes to a drain.
Okay.
This drain has other untreated water coming in and goes to one of our lakes or any other stream.
But the math doesn't add up.
During scarcity, what government did, This excess water, if it is mapped to a lake, you can send it to the lake. Lakes doesn't have water because it's meeting all the standards. You can send it to the lake. If an apartment had a network which goes to specific lake, they permit it. Now, when government permits things, people also take advantage. Why do I spend 1.5 lakhs to treat my STP water and give it to the stormwater drain? No one will know. I will not treat. I'll say 1.5 lakhs a month. I'll give the direct STP, direct raw sewage, who is going to measure to the drain, and it's going to the lakes. It's contaminating our lake. What NGT says, the central NGT says, the apartment cannot release any water to the drain. This is the first now. Now, to enforce this, it's not practically viable. Where would the apartment use this water? It's not practically viable.
People don't have time. If the water is coming in their tap and that's good, it's enough for them. Everybody in Bangalore, I mean, we have talked to many of societies around, all to the Manipal County Road. All are dumping it outside. Treated water, they are dumping it outside. But that is also not allowed from the government.
So government is now saying, apartments, you have to find a buyer for your excess water, and you are allowed to sell 50% of your excess treated water to any buyer who wants to buy.
And this is the norm. This is the law that says that you have to.
This is the law. If you have declared you have excess water, and if you have not declared, we will come and inspect. How you show us how you have not,
Right.
you don't have excess.
There are fines for it?
Fines for it. 1.5 crores for few apartments, they've got notices.
1.5 crore per apartment building.
Per apartment.
Wow. So if I'm a resident of that building, all of a sudden I have this huge big fine.
Yeah. Previously, the fines were 1 lakh, 2 lakh. They used to budget in their whole building budget. They used to budget. Now, recently, the fines have been 1.5 crores and things like that. People have started looking at. We spoke to BWSSB chairman. He said, why is the enforcement a problem? Why can't you enforce? Why can't you? What they say is, if 98 people are meaning wrong, how can we enforce? If enforcement is generally working for 2% of people who are faulty, then you can go enforce. How can you enforce 98%? So things like that will change now when the fines are larger and things like that. People know that they are illegal, and that's the first step.
The rules suggested that treated water to be sold to the commercial industry, such as the construction industry, but there are not enough takers.
And no builder wants to buy for the reason that it's not good quality. I can't risk my building because of this. This is the first issue. Second issue, now if you transport more than 7 kilometers, we'll be transporting more diesel than water,
Right.
effectively in terms
Right.
of cost. So it doesn't justify also to transport. So who's going to bear the transportation cost? Is it the builder or is it the apartment? Now builder says, I get water here at 2.5 paisa in my borewell. It's just the pumping cost. You're asking me to buy a very bad water from his perspective, it is not good quality, very bad water from apartment. You're asking me to pay for the transport, you're asking me to manage the entire tanker network, and you want me to store that in the tank, which I cannot use it the next day because it will smell, and you want me to use it immediately. How can I do it? That is the actual issue for the builder side. Apartment side, saying you buy our water, use it for garden. Builder says, my own wastewater I have, I treat it and use it for garden. So this is the current turmoil, meaning.
So this is the construction industry. What about other industries?
The quality of water little up and down is okay for construction because they use it for curing. All other industries need better quality water. So there is no way to send this water directly.
Let's now turn to the solution. STP is a pretty well-established process.
Instead of this excess water going to the lake, what we say is we go set up our equipment, we call it Boson Whitewater, where the STP treated water goes to our equipment. We produce water which is lower in TDS, total dissolved salts, being less than 70 average.
TDS stands for total dissolved salts.
Yeah. And then convert it to a very high quality water and supply it via tankers to industries or IT parks, malls, industries near the apartment. So the core technology doesn't change. It is just the efficiency improvement. If it was costing 40 paisa per liter in 80s, it is now costing 12 paisa per liter. So the efficiency is improved over time, but the technology has been same. So we try to use all the available technologies, how to make it commercially viable, and also it should last for longer. So that is a design patent which we have. So each stage removes different contaminants.
And how many stages are there?
In most cases 11, some cases 10. Say for example, we have to design a system in Whitefield where there is iron. The design changes a bit, meaning you put the third stage, the first stage, and all that.
Okay. So you change the sequence and perhaps even the number depending on what the issue is.
See here, like this is my feed which is coming to a plant. So the water will be passed through 130 micron filters. This is a micron filter. And then post that we have some kind of dosing systems. This is to alter the pH of the water.
Okay.
And then we have two stages of filtration. It's a media filters we call. These are all like advanced filter medias which are imported typically. And these filters are meant for removing certain type of contaminations present in the water.
Okay.
Like we call suspended solids, total organic carbons. So those things we remove here, and the water will go on to the next stage. So the water after this filtration media, it will be dosed with something called this is a chemical which is used in the treatment process. Then we have this 10 and 5 microns. So you see there we filter up to 130 microns and then post that 50, 65 microns we do here.
Right.
And then brought it to 10 to 5 microns here. This is where the particles up to size 10, 5 microns we remove here, typically suspended solids. Post the filtration, then we have the disinfection. We make the water to pass through the ultraviolet disinfection system here.
UV system.
UV, yeah.
Okay.
So any residual bacteria, virus, everything is there, we'll remove that here. And then the water will be ozonated with the ozonation system here.
So this system that you've got in this sequence, is this very typical of all residential societies or are there differences
Yeah.
that you put in?
Yeah, it depends. Like there will be small changes in the stages of treatment. Typically, it's one and the same. Maybe 1 or 2 stages may go or come up.
Oh, because their system was more advanced, therefore you only needed 2 filters. Whereas in a different society, you might need 3 filters.
3 filters.
Got it.
So post that we also have a couple of monitoring systems here. See, for example, we do a lot of treatments, multiple stages of treatment here. So we need to measure the system performance at every stage so that we come to know where the system is performing, where there is a need for maintenance or something.
So how long does the system have to run?
See, it depends upon the volume. Okay.
Yeah.
Say, for example, we have a storage capacity of 15,000 liters. So our system, what happens is, when the tanks gets filled up, system automatically cuts off.
Okay.
You don't see any of our operators operating the systems here. Everything is automated. So based on the tank level, system turn off, turn on.
Okay.
And it fills. Once it fills up, we'll get a notification. So then we'll allocate the tankers to come and pick the water.
So the tanker here right now is your tanker?
Exactly. This is come to pick the water from the site.
Acha.
So the water will be picked from here and it's going to one of the customer location. So the water will come here. It is free from any impurities. And the second most important thing is the water will get filled up. So we will be generating a quality slip which will be going along with this tanker. My customers are more keen on that quality slip because they don't get access to that kind of water and nobody is giving that kind of assurance when they get the water from.
Okay, so in terms of economics, you didn't have to put any capital investment in, right? So
That's the best part.
yeah,
You know, somebody.
because that's where things get stuck, right? Usually in a
Yes.
resident association.
If it was us who will pay for this,
Yeah.
believe me, this would have never gone through.
Right.
Asking resident to put in 20 lakhs
Right.
for a technology which nobody has heard till now.
Right.
For the environment, no.
Just walk us through the whole business model. How does it work?
Yeah, so we go approach apartments which are 250 units and above, right? 250 units above apartment will have an excess of 70,000 liters to 1 lakh liters every day. They will have excess. That's the excess water they will already have, right? Excess means after STP treatment. They will have an STP. After STP treatment, they'll use a portion for flushing, they use a portion for garden, and then the excess is 70,000 to 1 lakh liters. So it is costing them 1.5 lakh rupees, 2 lakh rupees every month to
Wow.
dispose this excess water. Now we go say, give us space, give us power. We come and set up the system at your apartment.
How much space do you need?
We need around 22 feet by 14 feet.
Okay.
So 2.5 car park area generally. So they have to give us plumbing line input from the STP to our system, whichever location they're saying, and tanker access point where we supply. So this external into the system, out to the system is their scope because they already will be having to dispose it to the tanker. Right. So we go set up the system at our capital.
And power, how much power do you need?
So 15 kilowatt for 50,000 liters recovery and 22 kilowatt for 1 lakh liters recovery.
Roughly give us in terms of cost. How much would it cost them?
So it doesn't cost them. We pay 8 rupees per unit for the power back to them.
Acha.
So it doesn't cost them. Now, then if they have our system, they become legally compliant in terms of not disposing the wastewater out. And they can safely talk about RO wastewater. They can, because they are not wasting large quantity of water.
Right.
Once we set up the equipment, then we identify the existing tanker in that region, whoever is handling the tanker distribution in that. We give our treated water to them and they go give it to our clients. So we find the buyer who needs this high quality water. They manage the logistics to give it to our buyer, right? Now each tanker goes with the slip, water quality slip, quantity slip, all that goes to the buyer. So when the buyer gets the slip, we take the money from the buyer for the water, and we recover an investment based on the buyer payment to us.
So for every building, apartment building you work with, it takes 3 to 4 years of selling water for you to recover your investment.
Now, for the apartment, we either pay rent for the space they are using, or we for every tanker which we sell, we pay 60 rupees for every 12 kl tanker we sell. We give one of these options to the apartment.
On the industry side, who are your customers and what kind of customers?
Yeah, cooling towers are buying, laundry are buying, electroplating industries are buying, silk industry is buying, plastic extrusion industry is buying, boiler industry is buying. So all those industries, semiconductor industry is buying. So all those industries which need high quality water for their process, they buy. When we treat our water, we take it to a very high quality which can be used for first predominant customers, cooling towers. No one buys our water for sustainability. Everyone buys our water for their commercial benefit.
Right.
I think that is the way forward for everyone to adopt.
Having looked at the problem and the solution, I was curious to understand what drove the founders.
We were Kannadigas living in Salem, so there was fight on that road. So we as kids were asked to go behind the building, if necessary, jump to the neighboring building if people throw stones. And in Karnataka, Tamil people were getting hit. In Tamil Nadu, Karnataka people were getting hit.
He went overseas to work but felt dissatisfied, like many of us. In 2008, like many other NRIs, he returned and happened to get into the water business partly because one of his father's friends. For 3-4 years, they supplied RO equipment to rural schools. The lack of clean drinking water was there for everyone to see. Kids had bent bones because of too much fluoride. But he soon realized that it was a waste of time because the NGOs that paid for these cared more about installing them and less about the impact.
In one of the schools, we went and put a purifier. So what happens, schools generally NGO support them. And next year I go there, that equipment itself is not there. We spent so much of time, efforts to exactly solve the problem. And next year some other NGO has funded, they put a different new looking equipment. And I realized we were continuing to do all these activities, but it is not really impactful. It is not one school. We did for 5-6 schools like that, 5 schools I think. So all the 5 schools, 1.5 years, the equipment itself is not there. Meaning someone has given money, some new system has come. So all the efforts were going wasted. So then I think we'll not do any of these. We'll do something long term which is going to help our cities. So that's when we started looking at wastewater infrastructure. So from 2014 we started looking at wastewater.
It's great to see another entrepreneur taking on a problem when they see it. It didn't take deep expertise in that area to come up with a solution, but a commitment and building of social capital. If you have a very good solution, but to scale that throughout the country, what sort of ways can you think of scaling your model?
So for a technology, it could be 6 months you scale fast. It could be 1 year. When we talk about infrastructure, we are trying to build the whole infrastructure for the country. It is always scaling over 30 years, over 40 years.
Who could you co-opt into this ecosystem, whether it's the tanker people or whether it's other STP plants? Who could you co-opt to make this scale faster?
Tanker can help, but they won't take technology deviation. They're logistic people, they're handling drivers. So STP would be a good starting point.
Could you like franchise your IP to them?
So it's more on, will they take this complex issue? Because see, it's easy to make money in STP. You do an STP, you sell it off, you make money out. Would they want to get into this complexity of solving the loop? No, that is the missing.
Okay, what if government policy steps in and makes them? Is that then scalable?
Yeah. So if government comes and says every STP vendor is supposed to manage their excess STP water, either they leave the business because it's too complicated, or they will find a way to find a buyer to sell that water. But generally what happens, it goes to the producer of the water. They are intermediate, right? They have designed a plant. It goes back to the apartment who is generating the wastewater.
Okay, so here's a
in case government is listening. Is this a solution? Is this them sort of stipulating that the STP goes and closes the loop?
Yes. So if that can be brought in a practical way where STP vendor can manage this wastewater, then that would be the first step.
I hope the story inspires more entrepreneurs. Thanks for joining me, Hansi, in the Climate Conversations.
As good as your fresh water.
As good as fresh water, which was actually more like this anyway when it comes, and then it becomes like this. You're drinking it?
I can also do
Bah.
No, you also have to drink.
Yeah.
because chlorine is not there. So
You said you were going to drink it. No problem. If they're drinking it, then I'm drinking it too. Okay then.
No order. No.
it's ozonated as well.
Cool. I also have pani puri from the street. So